Okay, let's go. So, yeah, welcome everyone. Good afternoon. This is a webinar around the EGI Cloud Services, more specifically around the EGI Cloud Compute, which is our, let's say, baseline service delivering cloud computing resources to our users. So just to frame a bit the service within the EGI Services for Research catalog, I have this first slide where I show the whole catalog of the services for research. You can see we have several areas. We have the compute. This is where the cloud compute services frame. The services in the compute area are about delivering computing resources for the researchers in several ways. Cloud compute is virtual machines, cloud container compute is containers, high throughput compute is mostly around jobs, software distribution is making software available in all those environments. Then we have compute orchestration, that is a set of tools that allow you to manage the compute services in a more easy way or in a distributed way, so you can handle multiple of the providers that are supporting the compute services from a single point. The applications deliver interactive notebook applications, so you can create shareable documents where you can do your research and create code, visualization, and text all together. Notebooks is a Jupyter interface. Replace is mostly a binder instance, so you can reproduce past research easily. Then we have the storage and data. This is all about having a place where to put your data. You have different ways of accessing it and providing it. So we have the data hub, a distributed store for accessing data transparently and independently of where it's located, data transfer to move data from one place to another, and online storage is the basic storage where you can just put your data, make it available for others. The security and identity are around, well, yes, that security and identity. The check-in is our identity and access management service. So it's the one that handles your accounts in EGI, that authenticates and authorizes you to the different services. And the secret store is about storing secrets that can be useful for any other of the services when deploying infrastructures or deploying services into EGI. The training allows you to get new knowledge about a service management system like FITSM or the ISO 27001 that is about security. And we also have a training infrastructure where you can run small to medium training exercises for your community. So going down into the cloud compute. Cloud compute is one of the, let's say, oldest services on EGI. It's mostly a distributed infrastructure as a service powered by a set of OpenStack providers that allows you to run any kind of workload as a virtual machine. That's meant to be flexible and customizable. You can run whatever you want with different hardware configuration, including GPUs, which is something that people lately request a lot, because GPUs are kind of the resource that is mostly needed for artificial intelligence kind of workloads. Besides the VMs, you can also manage block storage, that is a persistent disk volume that you can attach to the VMs, so you can have data that lives independently of the VMs. We have also a common virtual machine image catalog. That is a place where you can put your virtual machine images, so the software that you will run on the virtual machines, in a common place, and so it will be available across all the distributed OpenStack providers. We also have a dynamic DNS tool, so you can assign names that are easy to remember and easy to use, instead of just IP addresses, which are numbers that are sometimes difficult to use. And all of that is supported by a set of OpenStack providers distributed all across Europe and beyond Europe. We have more than 25 of those providers. Just to get to the very basics and what this service actually is delivering. So I will talk a lot about virtual machines. So I want to just give a very brief introduction on what a virtual machine is. So virtual machine is a simulated computer that runs within a physical server, and it has assigned a set of resources. So an amount of CPU, an amount of RAM, amount of disk, and all of that is managed by a piece of software that we call a hypervisor. From a user perspective, it looks almost like a real machine. It's just not running directly on the physical hardware, but running on top of this hypervisor layer. And it runs a complete operating system where you can install and manage whatever you want to manage inside of that operating system. The virtual machines start from what we call a virtual machine image. That's the physical disk layout of the virtual machine at the start of the instance. So you create the virtual machine from the virtual machine image, and that's the starting point. From then on, you can modify and do whatever you want. One thing that happens is that those changes are not persistent unless you put them in a persistent store, that is the block storage. So you need to create a volume that is kind of a disk that you plug into the VM, let's say, or think of this kind of USB stick that you put into your laptop, and that remains forever. So this is similar. You plug this volume into the virtual machine, and that data will just be there unless you delete it, of course. And all of this is done with APIs, meaning that you can not just go and click into a graphical user interface and do all this management of the VMs. You can automate this from whatever tool you want to use, or from a CLI, a command line interface, from any kind of tool. You can automate all the management of all this computing infrastructure. What the service is offering you? Mostly a computing infrastructure where you have complete control over it. You have your own operating system with root access. You can install any software you need for your research. Of course, with great power comes great responsibility. You are the one that needs to make sure that the VM stays secure and nothing bad happens with it. You also have custom hardware resources, so every VM can be different from one to another. We have what we call the flavors, which are a pre-configured set of CPU, RAM, disk, GPU, networking resources that you can assign to a given VM. Let's say you have small flavor, and that will have 1 CPU, 2 gigabytes of RAM, 10 gigabytes of disk, and no GPUs, just to give a very simple example. And that can be used for your VM instance, but you can have also large flavor with more CPUs, potentially 1 or 2 GPUs, and this can be easily swapped if needed. You can do vertical scaling, meaning you can move from one flavor to another, even in a running VM. And you can also do horizontal scaling, meaning you can have multiple copies of a given VM to handle your workload. And this can be started or stopped, again, depending on your workload. And everything, I want to really reiterate, the API base is very important because it allows you to automate anything or any operation you want to do on top of these computing resources. This is a high-level overview of the service architecture. So you see in the middle, we have these blue dotted boxes. These are the different providers of the service, the federated providers. They run OpenStack. That's an open source cloud management software that's quite used all over the world. OpenStack delivers the management of the user workload, that is the VMs and the storage. It has a series of components or OpenStack services that handle this. I just put here some of the ones that will be kind of more commonly named. The first one will be Keystone. That is what that handles your identity and authorizing your use of the service. That's integrated with EGI Check-in, our identity and access management service. So you can log in with your check-in identity. That means with your institutional identity, because check-in it's integrated with Edugain. Any university will be available for login with check-in. And if you're authorized, you'll be able to log in and handle your resources. There is the image catalog. This is where the virtual machine images are stored. And these are synchronized with what we call the artifact registry here on the left, with one tool that we call the Fed Cloud Control Panel, does this synchronization beyond other features that I will explain later. Other OpenStack services will allow you to create these VMs, create this storage. We have the dynamic DNS to assign names. And then we have other EGI tools that make the service fully operational. That is the accounting that collects information about the usage of the infrastructure, and the monitoring that checks that everything is working as expected. And you can access going through the APIs, through our command line client called Fed Cloud Client, or through the different graphical dashboards of the OpenStack. I will show it just in a moment. The EGI Cloud Federation is mostly in Europe, but we also are a worldwide federation. We have a few sites in China and South Africa. As you can see, it's quite well distributed all across Europe. It's a few more than 25 sites supporting right now the users of the EGI Cloud. In order to access the EGI Cloud, we use what we call the virtual organization. This is mostly a group of users and a set of resources allocated to that group of users. We have two main types of VO. The first one would be the VO access.egi.eu VO. That is a pilot allocation that is available for any researcher in Europe. You just request access to it. We will do a lightweight veto of your identity, just checking that you're a real researcher, and we will let you in. And you have 6 months to play around and see how it works with a real service for you. Of course, this is with limited amount of resources and opportunistic access. So, I mean, it's not meant for doing real production usage. Once you have played around a bit and understand how it works, we can move to what we call the production usage. And here we create a dedicated VO for you or your community. And here we have a negotiation process where EGI gets your full list of requirements, kind of what are the resources that you need, what are your constraints, and we talk with our providers and do a matchmaking. Once we find the right match, we create what we call an SLA, a service level agreement. That is agreement where we state what is the amount of resources, the conditions for accessing them, etc. So everything is clear, and we have expectations clearly set for everyone. And we do this following an IT service management based on FITSM. That's a service management standard. And with that, we ensure that we provide the agreed availability and reliability levels that we set with the user community. Once you're in, you can start using it, and we have several tools for making your life easier within this distributed infrastructure. I will start with some of them. So the first one is the dashboard. So this is available in dashboard.cloud.egi.eu. And this is a place where you can easily find all the entry points for our providers. So I will show it later in the browser, but basically here you can click on one of them and will allow you to log in and start managing your resources. When you are in, you will, well, the dashboard is quite complete, but just to show you a bit how a VM is created, basically it's a point and click interface. So it also can serve very easily, let's say, more novice users. So when you launch an instance, you can put a name, a description, you can select the size, and well, in the first place you select the image where you start from. You will have a list of images. I will show it also in the demo later, but just to have some idea now. You select the image, you select the flavor, meaning the amount of resources assigned to it, and basically you are done. You have a VM, and you can now log in into that VM and run whatever you want to run. You also can do this via the command line interface, and for that we have the FedCloud client, which is meant to be a simple command line client to interact with EGI Cloud Compute, but not only, it also supports other services of EGI. It's a Python library and command line interface, so it's widely available in Windows, Mac, Linux. You can run it almost anywhere. It's quite integrated with the whole EGI ecosystem. It will handle securely your credentials with this OIDC agent. It has discovery features, so you can understand which are the providers that are available for your VO. It allows you to run commands on multiple sites with just one line, so you don't need to repeat everything all the time you want to go to a different provider. You can use it in as part of a script, so you can have output that is easy to parse, even JSON output, so you can be used in almost anything. And you can also use it as a Python library. So if you are good in Python programming, you can just incorporate it into your Python script and just use it. There is a webinar on this. I put the link here. So there are lots of details on that webinar, so you can learn more about it. Another tool that we have for making the federation, this cloud federation, easy to use is the image registry. Here we have some news that are just coming in these days. We have this AppDB that is soon to be deprecated, but we have already a replacement that is operational. Both are meant to deliver the same functionality, a common image catalog, so you can share your software with your community easily. Here you see a screenshot of the AppDB where you can see the list of images. Anyone can go and upload images, and they can be run at any of the providers. And this will be automatically synced to the providers whenever a VO says the image is good for them. So we have what we call the community level management of images. Every VO decides, I want image for Ubuntu and CentOS, and that will be the one that's available for me or for the community at the given providers. And also has some basic support for containers, only dealing with metadata in this AppDB. We're transitioning to a new system that it's based on Harbor. That's an open source CNCF graduated project. So it's quite, let's say, standard technology. So it's easier to maintain. It supports containers, but also other artifacts, mainly images, which is the one that we are caring more in this service. It's already operational, and we have what we call projects, which would be equivalent. We have already EGI built images there. You see here the list of Ubuntu, Alma Linux, some ready to run Docker on top of them, or some more custom with Jupyter installed. So that's already available. Now we also have opened this for VOs having their own projects. So if you're interested in doing that, just contact us. And we are working on the synchronization with the providers. So we expect that this will be soon really operational and really capable of syncing with the provider. So everything works as it's working now with the AppDB. Dynamic DNS is another tool that it's meant to make your life easier, provides names that can be used at any site. You register a name, and then you can associate an IP to it. So that way you avoid using just IPs, which are subject to change, and if we move from one provider to another, and it's harder to manage. And also allows you to request certificate. That it's quite useful if you need to provide a service that is accessible by external people. It's very easy to use. I also will demo it in a moment, and you have also a webinar to learn more. Here's a link. Just to show a bit things that happens, not so much user facing, but behind the scenes that made the operations of the service just happen. First would be the monitoring. We have a set of checks that make sure that the providers are working as expected. We have 4 checks mainly. The first one, is it reachable? So So the provider is there up and running. The second is trying to mimic the user experience. So we start a VM and make sure that it really starts, and then we delete it. So we reproduce what a user would normally do. Then we have another test that checks that the accounting information is really being produced. So if we have information from the site clearly delivered, and we also make sure that we can discover properly the features of the site. So that allow us to have any automated tools relying on discovering the site just working. And all of this is run with Argo, which is a system that is also used in EOSC, the EOSC core for monitoring, and we calculate this availability and reliability in the last, well, you can specify the period, but normally is within a month. So you see here one provider. In this case, it was mostly available during the whole month, just 2 days. You had some issues. You can click and understand what was the issue, if it's affecting your workload or not. Then we have the accounting. Is also something that we use for making sure that the whole service is operational. This is automatically collecting the usage information from every provider and community, and also making it possible to visualize it easily from a portal, which is accessible here, accounting.egi.eu. And here, well, this is a screenshot where we are showing all the different providers as, in their countries. And you see here the number of CPU hours over the last year for the different countries. I can also show later a bit how this accounting portal works. And then one thing that we also have to making sure the service run as expected is the Fed Cloud Control Panel. This is not so much user-facing. It's more for the people running the federation, but it's quite helpful for us. And this is something that has been developed over the last few years, so it's constantly being improved. And what we have here is the Cloud Info Provider that collects information about all the providers, so we can enable automatic discovery of the features. This is quite used in high-level services like Infrastructure Manager. So Infrastructure Manager can show you the different providers without you needing to enter the details. We have the image synchronization, so what I was saying before, making sure whatever is in AppDB appears also on the providers. We have this FedCloud BMI templates. That's automated building of the images, so you can have the latest and greatest operating system always available for you. We have the dashboard. That's that web interface where you can easily go to your provider. And we have a set of tools that allows us to understand whether the site is properly functioning. For example, it allows you to check that the quotas are correctly set, that the accounting is working as expected. Well, all these kind of small details that allow us to troubleshoot any issue whenever that happens. Some communities relying on EGI Cloud Compute. There are lots, but it's true that most of them are using also higher level services. So I wanted to kind of put 3 that go into the very basic usage of EGI Cloud Compute and just use that bottom layer and not go to Infrastructure Manager, which would be the kind of the typical entry point for lots of communities. So these 3 just examples. IceCube is about high energy physics. So this is a neutrino observatory, and it uses EGI Cloud to provide a distributed pool of resources to run GPU-based workloads. So they have an allocation in multiple providers of the EGI Cloud with GPU enabled, and they just configure Condor on top of that, and they can run jobs easily on top of the EGI infrastructure. Then we have MBIS. MBIS is the National Bioinformatics Infrastructure of Sweden. And here, again, they have allocations in the EGI Cloud, and they deploy web portals where you can easily go and run different life science tools just by by clicking in this portal, and it's available for any researcher worldwide. Another example is OPSI. This is a ground-based cable observatory that is in Spain. And here we have one provider that is supporting this community, and they host their data acquisition and data visualization services in mostly one VM that it's kept operational all the time, and they can just keep all the data there for anyone to use. And in particular, this one is then harvested by EMONNet, which is the managing observation data in Europe. So again, these are 3 examples, but there are more. And lots of them are using the cloud indirectly by relying on other services. For example, we have the Cloud Container Compute, which is a managed Kubernetes powered by Rancher. So this is a way to get access to Kubernetes without dealing with the low-level VM details. So it's also available in a webinar for more information. You can learn more about it. Then we have Infrastructure Manager. This is a tool that allows you to automate the deployment of infrastructures on the EGI Cloud, meaning that you can just, let's say you need to deploy a cluster to run Slurm and run jobs on top of that. So you don't need to go start each of the individual VMs, configure the operating system, install a Slurm, configure a Slurm, making sure everything works. IAM will do all of that for you, following some recipes, and we'll do it in any of the providers of the EGI Cloud. Again, just point it and click, and you can just do it. It also has an API, so you can automate it if needed. There is also a webinar around that if you want to learn more. And there is also one convenient tool that can be used alongside all of these. Normally, when you deploy anything on an infrastructure, there will be some secrets around it, and it's good to have a place to securely store those secrets. And the secret store of EGI just helps you to do that. So you can put the secrets in that service, and then you can easily access them from the EGI Cloud infrastructure. There is another webinar on that, so you can learn a lot of that service there. We are in constant evolution, although this service is quite stable in the sense that it's been running since quite a long time. So the basic features remain the same, but we are trying to improve it little by little. So what's coming is this artifact registry that I was mentioning. AppDB is becoming this artifact registry based on Harbor. We are working on this image synchronization and completing it. We have already the people working on that. And with that being complete, we will fully deprecate AppDB and move everything that's in AppDB to this new registry. Dynamic DNS is also evolving. Right now, it's quite based on the web interface, so we want to make it more API accessible. So we want to make it possible to automate all the workflows, so you don't need to go to the web interface, but just doing everything from the API. Also, for better control of the names, we want to include expiration of the ones that are not used. So we make sure that the things are consistent all the time. We are working also on personal projects. So I told you in the very beginning, we are based on virtual organizations. So normally when you enter a virtual organization, you reach a shared space where you can see the resources from others. So we are working on making these isolated personal projects just for one person. So you just see your thing. On the information discovery, we're working on a new API. So it's easier to use that information from an external third party. And we are also working on having better discovery of GPUs and high performance networks availability. So you can also discover that capability and automate any usage of those resources. And regarding EOSC, it's a moving target right now, EOS, because now we are entering in the phase where we have the EOSQ node and new nodes will be coming. EGI is looking to become an EOS node, And of course, the EGI Cloud Compute will be part of that offering. So we are working to make sure that we meet all the requirements of the onboarding of EOSC as a node will be also met as by the EGI Cloud Compute. And one thing that we already have in place, we have this infrastructure manager that is able to talk with our EGI Cloud Compute service, but it's also capable of talking and interacting with the EOSC node compute resources. So you can already, from the EGI infrastructure manager, deal with infrastructures that are running in the EOSC node. So that's already available. So if you have an allocation, you can, from the EGI IAM instance, also manage those resources. So some pointers, this will be available for you later on if you want to check. First one is documentation. We try to have up-to-date documentation for everything, but if you notice something is missing, just let us know and we will provide it. And everything that we do is open source. So OpenStack is open source, but all the tooling that we have around the OpenStacks and our service is open source. And you have their pointers to the repositories where the code is available. Not just the code, also the deployment of several of the tools is available there, so you can replicate that if you're interested. So I want to go to a bit of demo part, if that's okay. I just want to kind of show how to start a VM in one of the providers. So I want just to start from the applications database. Here, well, I log in, so maybe it's not what you will see as an anonymous user, but at the end, what you have here is the cloud marketplace, and you have here a list of images. As I said, anyone can go and publish them. EGI produces a set of images that are, let's say, well configured, and we make sure that they will run properly at any of the providers. So they are named EGI something. For example, this EGI Ubuntu 24.04. Okay, so this is an image that is created by EGI. It's regularly updated. We, at least every 6 months, we produce a new image. And if there is any issue, we'll always produce a new image. So making sure that we have the latest version up and running. Also in the AppDB, we have the virtual organizations. And just to show you the access PO, which is this pilot infrastructure, will have some VM images associated with it, and we have them here. So basically, it's the EGI images. So we try to make sure this virtual organization has the right configured images for anyone to use. So if I go to a provider that supports this poaccess.egi.eu, I will see those images available there, and I will show you just in a second. The new thing that we are providing is this artifact registry. I think, yeah, I need to log in, but I'm already there. So this is how it looks. If you are familiar with hardware, it would, yeah, look familiar. We have these EGI VM images. As I was saying, this is the images built by EGI. This is Ubuntu. It's a bit different from the AppDB, but here you see this Ubuntu 20 or 24 or 22. So we are building the same and publishing them in also in this place. Just going to the dashboard, and I will go to this provider. This is the one in Turkey, TÜBİTAK. I will be redirected if everything goes. Yeah, well, let me log out and log in because I was already logged in. So when I click, I will go back. Yes. I will be shown this page. I select check-in as a way to log in to the provider. It will check my identity. I am already logged in and check-in, so it will just reuse my information. And here I am. You see, this is my check-in ID. Well, it's some number at EGI.eu. And here you see VO access to EGI.eu. Okay, I have access to other projects in OpenStack because, well, I have membership to that other VOs, but the one that we are interested right now is this VO access to EGI.eu. If I go to images, I should see the images I was showing you in the AppDB. You see this? Okay, that shouldn't happen, but you see here, these are the images that are in the AppDB, the Ubuntu, Docker, etc. Okay, if I go here, I will see the different VMs that are running now at this provider. Seems not super fast. There are some running. I will just start one. So I can click on launch an instance. I will put it a name. Say test webinar. Just put something. Just one. Source will be an image and will be this Ubuntu 24. The flavor, I will put something small. So it will have 2 CPUs, 2 GB of RAM, 40 GB of disk. And network, I will just set the default. I will also set a keeper that will allow me to SSH to the image. I have already my keeper in the provider, but you can easily just click here on create keeper or import keeper to import yours. So this will allow me to log in, and I'm done. So I will click launch instance, and this will just start. While this is starting, I will just go to the command line, and I have my Fed Cloud client here configured. So this is Fed Cloud client. This is the command line of EGI. I can do Fed Cloud, OpenStack. The site that I will use is called like this. The VO that I'm using is voaccess.egi.eu, and I will list the VMs. That's server list. Okay, this wasn't expected. Demo time, always funny.
Don't worry, I know it's we understand.
Yeah, I was not expecting
with,
this. Let me just try with another site, and I will show you. Just to show you that this works. Sorry about that. I probably did something wrong while I was preparing for the webinar. So I'm just listing another provider, and I can go just to the dashboard in a second. So this is a provider called Sky, and I'm doing the server list. And here you can see the list of servers that I'm running. And I can just go here and go to Sky. Here it is. I can log in. And this view that you see here, all this information that is in the dashboard, is the same that I can get here. So I can get information, detailed information from one of the instances. Let's say I will just show this one. See here, I can get all the information. So it will give me well, everything. You can see the IP addresses. You can see how the different volumes that it has attached, the size. This one is small, etc. Just going back to the VTAC, because this is the one that I started. I want to show kind of the whole flow. I have created this one. It's already active and running. I will now associate a public IP to it. You see it has an IP address, but this is a private one. By default, the VMs will start in a private, isolated network. So if you want to make them accessible, you need to allocate an IP address to that. I have already IP address allocated, but if I click on this plus, it will be just allocated for me. So I will associate it. And now when this is done, my VM will be accessible in that IP. Save it once. Okay, you see the IP. So now I can go to my terminal and just say we want to add this IP. And since I have configured the SSH key, I'm in. So I can now do whatever I want. Let's say I want to install here an Apache server, just to do something very simple. That I could potentially expose into for the world, let's say. Of course, I didn't put sudo. And while this is going on, okay, this is just being installed. Okay, so now I will just start Apache. So this is working. So now if I take this IP and paste it here, will not work. Why? Mainly because I didn't open the access to it. So I need to deal with the security groups. I will add the HTTP that opens the access to the web ports. And now you see it's already working. But this is not the nicest thing. So one thing that I will do is go to the dynamic DNS and create a new host. Let's say webinar test. I will just choose this domain. I will create. This is created. This is the one I just created. I can put the IP. It was here. So if I now use this name, I should be also reaching the same place. So now I can easily share this with others, and it's not just a number. And if I create another VM that will have another IP, then I can still use that very same name. That's kind of everything I wanted to show. So I don't know if there are questions, comments. All of them are welcome. I go back to the